The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thank you for joining us for the first webinar of our upcoming webinar series in regards to municipal concrete pavements. Today we will be introducing what concrete pavements are all about and why municipalities across the province should consider concrete as a viable solution. Upcoming webinars will be featuring construction practices, troubleshooting, and several case studies of recent municipal projects, which will be presented by municipal staff. My name is Alan Carey, and I'm the Director of Technical Services at Concrete Ontario. I have over 13 years experience in the Ontario ready-mix industry and have been spearheading the concrete paving initiative at the association for the last few years. I will be your facilitator for this webinar and all upcoming webinars. Now, just some housekeeping items before we do get started. This will be approximately a 45 to 50-minute webinar, and we will leave some time at the end for questions. All participants are muted and will remain that way for the remainder of the webinar. If you do have a question, please use the GoToWebinar questions pane on the right side of your screen and type in your question. We will address all questions at the end. The webinar will be recorded and posted on the Concrete Ontario YouTube channel. And to make it easier for everybody to access the recording, we will be sending a PDF version of the presentation and a link to the YouTube video that will be emailed to all participants in the next couple of days. Now, in terms of the agenda, this is what it looks like. We'll be introducing the Ontario Good Roads Association Municipal Concrete Liaison Committee. We'll be overviewing the Municipal Concrete Paving Guide. I'll provide an overview of the concrete pavements in Ontario, what's going on there, and then I will turn it over to our presenter, Tim Smith from the Cement Association of Canada, to look at concrete paving benefits and concrete paving basics. Now, the Ontario Good Roads Association Municipal Concrete Liaison Committee has been very busy, and it's a committee that was formed back in 2012 to help address any concrete-related issues on the municipal front. So whether you're looking at sidewalks, bridges, ordering concrete, the committee looks at providing guidance to municipalities about how to do things properly and educating them about emerging trends and specifications. So currently the committee is made up of a bunch of municipalities. You can see them here: Waterloo, Orillia, Thunder Bay, Vaughan, Durham, Kingston. Then we also have contractors on the committee. We have ready-mix suppliers. We have consulting engineers. We have a representative from Ryerson University, Dr. Shahada. And then we also have 4 associations. So everybody works together to try to improve municipal concrete infrastructure in Ontario. Now, as I mentioned, the committee has been quite busy over the last few years. We developed 3 different guides. The first guide, the best management practices for municipal concrete infrastructure, is again an overview of all sorts of different infrastructure related to concrete, and just some best practices guides on how to maintain it and how to build it. Then 2 years ago, we focused more on flatwork construction. There's still a lot of problems when it comes to sidewalks and curbs, and we wanted to specifically drill in on that subject to help municipalities out, so we developed that guide. And then last November in 2019, we developed the Municipal Concrete Paving Guide, which we will be overviewing today. And here on the next slide. So this guide has been a few years in the making. It's really showcasing all the different projects that have been done over the last few years. They're all local Ontario projects. The guide will continue to be updated and will continue to emphasize the many different applications that concrete makes sense, whether it's a bus pad, a turning lane, an intersection, a road, a roundabout. There's many applications where concrete is simply the superior building material, and that's something we want to showcase in this guide. It is a free document. It's available on our website, and it can also be accessed from the handout section as part of your GoToWebinar pane. Now, it is an interactive guide, and what do I mean when I say interactive? Throughout the document, you will find these little PDF icons that say there's an available resource. You can click to explore it. If you do click one of these PDF icons in the document, you're able to access all sorts of supporting information Documents such as the Integrated Materials and Construction Practices for Concrete Pavement Manual, which is developed by the National Concrete Pavement Technology Center from Iowa State University. They also have, concrete pavement distress assessment and solutions. Then we also have, for example, an American Concrete Paving Association Concrete Intersections Guide. We also work with the University of Waterloo and their CPAT program on a project, so that report is available. And then even OPSS standards when it comes to concrete pavements are also available as part of the guide by using one of the clickable links. Not only do we have supporting documentation available, we also have this other icon throughout the guide, which is a little video guide. And if you do click any of these video icons, you can pull up YouTube videos when it comes to either construction practices or specific construction practices such as vibratory trusscrete paving, for example, here on the screen, transverse tining, curing. There are a few videos available from some of the projects that you can access using this other icon. Now, when it comes to concrete pavements in Ontario, you will see only about 5% of all roads are concrete. In Ontario, Windsor has the highest percentage of exposed concrete pavements, so you're looking at about 40%. And other provinces, for example, as a comparison, in Winnipeg, you're looking at about 80% of the street network is concrete pavements. So why is it such a small percentage in Ontario? There's numerous misconceptions when it comes to concrete pavements that we do need to address. One, for example, is that concrete requires 28 days to cure, which is completely false. Curing relates to maintaining moisture within the concrete to allow it to gain its durability and strength. And the way we achieve curing with concrete pavements is you spray on a curing compound, which again is very, very quick procedure. You spray it on, it traps the moisture within the concrete, allows the concrete to hydrate and to gain all its properties. So again, curing is very, very quick. The more important aspect is strength gain. You do need about 20 MPa to open concrete pavements to traffic. So 20 MPa out of the designed 32 MPa Class C2 concrete. And that can be typically achieved with regular concrete in about 4 to 5 days, depending on the ambient temperature. In the summer temperatures, obviously you're going to achieve that strength a lot faster versus fall and winter temperatures. But there are many, many other mixed design options, thousands of options where you can use accelerated concrete to get to your 20 MPa within 24 hours, within 48 hours. So strength gain is not a problem when it comes to concrete pavements, even though there's a lot of misconceptions about that. The other misconception is that concrete is more expensive. Now, if we're looking at initial cost, concrete can be more expensive. But if you look over the entire life cycle analysis of the design life of the pavement, you are going to find that concrete is more durable. There's very minimal maintenance when it comes to concrete pavements, and overall it will be cheaper from a life cycle cost analysis, and more municipalities need to factor that in as part of their road rehabilitation toolbox. And another misconception is all about utility cuts. Municipalities believe that utility cuts are not achievable, that they're very difficult to execute. It is more challenging doing a utility cut. However, if you do have a step-by-step procedure that numerous states in the US are using, it is not that difficult to drill in dowels, re-pour accelerated concrete, and you can open up that road very, very quickly, minimizing traffic, minimizing, again, congestion. So utility cuts can be done, and it is something we will address in future webinars that will be coming up in the next few months. Now, one thing I do want to quickly talk about are potholes. Now, we all experience potholes. It is a major deficiency when it comes to asphalt roads. They're dangerous. They can damage your vehicle very severely. But one great feature about concrete is that we do not have potholes. Concrete is a rigid structure that doesn't deform, and overall potholes can be completely eliminated if you use a concrete pavement. Now, just to give an overview of how potholes are actually formed, I'll just show you guys a quick video here.
Potholes form when water seeps into the road and collects underneath. When it freezes, it expands and pushes up the road's surface. As cars drive over it, more cracks form. Eventually, the sun returns and thaws everything out, including the water trapped below the road's surface. It causes an empty pocket to be formed, and that eventually collapses under the weight of traffic, and then it leaves behind a pothole.
So very quick explanation of how potholes form. And why am I talking about potholes when it comes to concrete paving? Well, it's something that boggles my mind every year. For example, the city of Toronto spends about $25 per pothole every single year. And they budget about $4 to $5 million of their annual budget towards this problem. It takes about 15 to 20 minutes to fix each pothole, and they expect to fill about 200,000 potholes annually. Now, in 2020 so far, they've already fixed 86,000 potholes, and they fixed 12,000 in just the past month since everybody's home with COVID-19 isolation. Crews are able to get out there and have fixed 12,000 potholes just in the month of April alone. Now, their budgeted cost for road repairs, rehabilitation, and maintenance work is about $220 million, and of that is $5 million just to repair potholes. So far, the city of Toronto has spent $2.1 million approximately on potholes already. They will be projecting to spend another 2.8 by the end of the year. But it is very mind-boggling that we spend $5 million a year fixing a problem that will continue to happen. So John Tory even tweeted last year, potholes are a nuisance, they can be dangerous, and then he kicked off the annual pothole blitz of fixing potholes. And then it's being glorified that how many potholes can be filled, 74,000. This is a tweet that was sent out last year. They already filled 74,000 potholes at this point, and it continues to be an issue. So this year, again, they tweeted just on the weekend, city staff will work a 12-hour shift today, and using appropriate physical distancing measures, which is important. They fixed 12,000 potholes last year, as I mentioned, and today alone, so this was May 2nd, 48 crews and 146 people will be repairing potholes. Now, this really boggles my mind, considering there is a better solution, there is a better alternative. And this great picture over here, when I saw a picture, the first thought when I came to a quote was, maybe we should try concrete. Maybe there's a better solution to all this. Maybe we shouldn't spend $5 million trying to put a Band-Aid on a broken arm. This will not go away, and maybe we should look at an alternative when it comes to road maintenance. Now, your presenter today is Tim Smith. Tim is the Senior Director, Built Environment, Transportation, and Public Works for the Cement Association of Canada. Tim has over 25 years experience in concrete pavements, and he's also previously worked with the New Brunswick Department of Transportation, Marine Atlantic, Lafarge Canada, Englobe, and Stantec Consulting. So I just want to welcome Tim to the webinar. Good morning, Tim. How are you?
Morning, Alan. Thank you very much. I'm doing well in the basement of my home, being isolated.
Amazing.
Unfortunately, with the
yes, thank you for joining us.
Unfortunately, go ahead.
Yeah, thank you for joining us, and I'll turn it over to you to take over the presentation when it comes to basics and the benefits of concrete pavements.
Okay. And Alan will be actually changing the slides to make sure that we didn't have a mess up in transferring it over to myself. So next slide, please. The hallmark of any concrete pavement is the longevity and the durability. These are just a few slides showing the one on the right. Winnipeg, taken in 2011, the concrete pavement had been over 100 years old at that time. And you can see there's been very little maintenance done to it. Concrete, if maintained properly, will not get potholes. There is a potential for development of deterioration at the joints, but if the joints are well maintained, you will not have potholes developing. The main part of the concrete is a rigid surface, and it will not rot, and it will not have potholes. The other one on the left-hand side is the City of Toronto. Again, I didn't have a date on that photo, but again, it's a very old concrete from 1890 that was still in very good shape at the time the photo was taken. Next slide, please. So what we're going to do is we're going to show you the cement, concrete, and aggregates industry in Australia developed a video trying to show the benefits of concrete pavement. The American Concrete Pavement Association took that document and modified it. So the next slide will be a little video on why you should choose concrete, why you should look at choosing concrete pavement.
Concrete roads are the strongest and most durable, performing better under heavy traffic loads and lowering costs across the lifetime of the asset. And because concrete is rigid, it doesn't deform, leading to heavy vehicle fuel savings in the order of 4% when compared to alternatives. Concrete pavement is also durable in any environment. No rutting, no potholes, no shoving. Concrete road surfaces are engineered to be skid resistant, and in fact, stopping distances are shorter, especially in wet weather. Safety is a clear advantage when using concrete pavements. Concrete roads are lighter in color, so they reflect more light and heat energy when compared with dark surfaces. In fact, studies show they are twice as reflective, which can contribute to a lower urban temperature, enable energy-related cost savings, and improve nighttime visibility and safety. With concrete, you are choosing a solution that can deliver lower ongoing costs. In fact, independent studies have found that concrete pavements compared to asphalt alternatives can reduce ongoing maintenance costs by over 50% and deliver savings in the order of 25% across the life of a major road project. And a product that is fully recyclable with high local content and raw materials from local manufacturers. A product that is resilient, standing up to extreme weather without melting in the heat or weakening after being inundated from floodwater. And its innovative, low-noise, smooth surfacing makes for a quiet ride.
So to kind of summarize, there's a number of, beyond the longevity aspect of the concrete pavement, the decreased maintenance that you would have, there's also some environmental benefits that you can look at. So if you hit the next button, so better fuel consumption, as we stated, and there will be a short video on that we have with the research that's done by NRC. Next one. Less fuel consumed during construction. Here, because the concrete pavement structure has a substantially less gram of material, there's a lot less movements of material coming into the job site. So your construction is consuming less energy that way. You have recycling of byproducts. You can use fly ash, blast furnace slag in your mix. It stabilizes them within the concrete and improves the quality of the concrete, but also prevents it from going into a landfill. You have non-renewable, better light reflectance. Concrete actually reflects light in a diffuse manner. It's like taking a ball and throwing it into a pool. The water splashes up at all angles. Or asphalt, when it's spectral. When you throw the ball, it's like hitting the ground. It'll bounce up at one angle. So you get better light reflectance on a concrete pavement. Next slide. Enhanced riding comfort, because you're not going to have the running and shoving that you potentially have. And there's also reduced potential for hydroplaning. I have a slide on that shortly. And then the final thing is innovative surface textures. You can actually do grooving and grinding in the concrete, put longitudinal tining, which is very quiet and actually makes the concrete very smooth. They did a test section of the grooving and grinding process that they did down in the London area on concrete pavement placed, I believe it was last year, the year before, and the IRI was very low, I think around 0.7. Next slide, next one. And then the main binder in concrete is cement. The energy footprint in the cement is compared to the main binder in asphalt, which is liquid bitumen, which is a natural source of feedstock energy. So the energy in the construction process and in the overall pavement is less than concrete pavement. Next slide. So when I'm talking about reduced potential for hydroplaning, one thing about concrete pavement, whether you have a transverse tining or longitudinal tining, you have the macro texture. That's the tining within the concrete to allow the water that's on the pavement to go in those grooves, and when the tire crosses the pavement, the water will go down and be pushed out from those areas. So it maximizes the tire pavement interface. Also, there's what's called a microtexture. The microtexture is the surface of the concrete, and in that, if you have high silica content in your sands, and also using a burlap drag, you get a very good skid resistance friction value for your pavement. Next slide, please. So this is just to highlight the better light reflectance, and I mentioned about the diffuse versus the specular manner of the reflection of the light. But you do have a better illumination on the concrete in the evening than you do on an asphalt. Next slide. So this is the slide I was talking about for National Research Council of Canada actually did a series of studies looking at the fuel consumed in concrete versus asphalt. They used a van semi-trailer, they used a tanker semi-trailer to analyze what the fuel consumption was. And the theory behind it is that being a rigid pavement, concrete pavement would actually deflect less than an asphalt pavement. So here in the diagram, we're showing that the deflection and the fuel consumption and a bit of a bow wave, of course, is exaggerated in the picture here just to show you that there is a bit of resistance when the tire goes over the pavement. But as you proceed from the asphalt onto concrete, you'll notice that the deflection is less. And MIT did a study on this as well, and they noted that the stiffness of the concrete pavement had around a 3% fuel savings. And NRC's research, depending on whether you have a van semi-trailer or tractor semi-trailer, the savings went from 1% up to 7%. So there definitely is a fuel savings that you can take into account when operating in concrete versus an asphalt. Next slide, please. So what I've done here is show an example of an asphalt versus and concrete together to show the cross section of the two pavements. And you notice that the asphalt pavement structure is thicker than the concrete pavement structure. And the reasoning behind that is to have an equivalent pavement design, asphalt being a flexible system, you'll deflect the load through the asphalt down to the base, down to the sub-base, and down even to the subgrade. I'll have a picture showing that in a minute. For concrete, most of the load is taken within the concrete pavement itself. Now, concrete can be, as you see here, ICP, that's interlocking concrete pavers. There's pervious concrete that can be used in certain situations. There's roller compacted concrete. There's conventional concrete. And you can do cement treated bases or cement modified soils. There's a lot of different aspects that you can do when you're looking at an overall pavement structure. Next slide, please. So I mentioned asphalt is a flexible pavement system. So when you're looking at two equal loads, the load within the within an asphalt is transferred through the asphalt down into the base, sub-base, and even down into the subgrade. So you get a higher pressure down in the subgrade than you do in the concrete because it's more of a point loading. Concrete itself, being a rigid structure, it spreads that load out over a much greater area so that you have less pressure down into the subgrade area and less pressure, of course, down into the base and subbase if you have both the base and subbase. Municipal operations, a lot of times you'll just have one layer of grinder material. That would be the grinder type 1 or the grinder A, depending on where you are, what province you're in. Next slide, please. So what are the basic components of concrete pavement? First of all, concrete, when it's placed, will be its maximum size. You normally have, with the Class C2 exposure concrete, you have a water cement ratio maximum of 0.45. You need 0.25 to around 0.26 to have complete hydration of the cement. So there's a lot of excess water that has to evaporate out of that concrete. So because of that, you want to control the cracking. So to control the cracking, you put a longitudinal joint in the direction of the traffic, and then you're going to put transverse joints into that pavement. The transverse joints, depending on the thickness, will vary anywhere from 4.2 to 6 meters if you're into a pavement for an airport. And if you're going with thinner concrete pavements, you'll have joint spaces that could be 1 meter. All depends on what you're looking at in the design. So the transverse joints are put across perpendicular to the direction of traffic, and those are going to control the cracking in that. The longitudinal joints are in the direction of traffic. You also will put a tie bar in the longitudinal joint. The tie bars are usually 15 m and around 450 to 460 millimeters in length. Those are used, they're ribbed and they're epoxy coated, and those will actually keep the concrete from drifting apart in the longitudinal direction. You have a lot less expansion and contraction, but there's no confinement on the sides of the pavement, so you want to hold that together and not create a maintenance problem. Across the transverse joints, you'll put a dowel. If the pavement is around 200 millimeters, you'll end up using the dowel in that. And the dowels are round, they're not ribbed, they're smooth, they have a tactile coating on it to allow the dowel to move and expand when the concrete expands and contracts. And that's used for load transfer. So that's basically to prevent the thump, thump, thump that you sometimes see in older concrete pavements that didn't have dowels. That's because they faulted. And I have a picture in that shortly. So underneath the concrete is normally a base. Sometimes you have a base and a sub-base. And next slide. So here's just a profile shot. Now put the 14 to 20 meters, the feet, that's 4.2 to 6 meters is the normal spacing on the concrete pavement, unless you're going thinner pavement that's bonded to an asphalt below, then your joint spacing is lower, or you're doing a composite pavement. And you'll see the plan shot here, it's aggregate interlock. When you have aggregate interlock, when you're doing your transverse joints, you're normally cut at 1/4 the depth of the concrete, unless you have a dowel, as you see in the profile, the green dowel. When you have dowels, your transverse joints are cut at 1/3 the depth. Longitudinal joints are always cut because it's a long distance. They're cut at 1/3 the depth of the concrete. Next slide. And why do you need to cut these joints? Well, the cement particles are going to absorb the water, the moisture, to hydrate. So when it's doing that, the meniscus is formed, and there's a surface tension that develops. As it gains more and more water, the surface tension starts to increase. When concrete's first placed, it's in its weaker state, because it takes time for the cement to hydrate and for the concrete to gain strength. So what happens is, when the tension is stronger than the concrete strength, you get a crack. So to prevent that from cracking randomly, you cut the joints. Next slide. So when you're cutting the joints, you're going to use a saw. That saw can either be an early entry saw, and that if you have an early entry saw, you can get on the concrete within 1 to 2 hours. And you're normally cutting it to a depth of 1 inch to 2 inches, depending on the thickness of the concrete. If you're using a late entry saw, your timing could be anywhere from 6 hours to 12 hours, but you have to understand that the concrete will start to crack. And if it actually, when you're doing your cutting of the joints and you do get a crack developing in front of the saw, what you need to do is stop, because that's already starting to crack. You leapfrog 2-3 joints, relieve some stress on the pavement, leapfrog a few more, and then you relieve the stress on the concrete. Then you go back and cut the intermediate joints, so that you'll make sure that you have all of the joints operating. Next slide, please. So why do you need load transfer devices? Well, if you have a lot of heavy traffic and your pavement's in the 200 millimeter range, you're going to need to have some load transfer assistance, because over time, that aggregate interlock that keeps the transfer of the load from one slab to another will actually decrease. And to the point where if the traffic is too much, you'll end up getting a poor load transfer, and you'll start getting faulting. And what happens is the lee slab deflects when the tire goes off onto the next slab. The slab will rebound up and the other slab will go down, and starts creating a pumping action. That pumping action, if water is available and there's a source of fines, that'll pump the material out to the top, through the top or to the side of the pavement, creating a gap underneath the pavement and creating that drop in the slab. And that's the thump, thump, thump that you get from older concrete pavements that don't have dowels. So you can retrofit dowels if you have an older concrete pavement, which I believe the Highway 427 in Toronto has had dowel bars retrofitted in some cases. And the dowels will vary in size from 32 to 28 millimeters, 32 to 38 millimeters, and that depends on the thickness of the pavement and the loads that you're dealing with. Sometimes slabs in the 150 to 175 millimeter range will have dowels placed in them too, but the dowels have to be thinner. They go with the 25 millimeter dowels to ensure that you don't expose or hit the dowel when you're doing your joint, cutting your joint. Next slide, please. Now, what I'm going to do is just go over a few different projects. And this is a project that I actually, before I went back with the Cement Association of Canada, when I was with Englobe, we were given this design to do this concrete pavement at the fire station 7-3. Now, this is a very complicated pavement jointing pattern here that we have here because of the configuration of the area. So what, instead of going with dowels in this job and going with around a 210 millimeter with dowel, we went with the 250 millimeter no dowels to minimize the construction issues and putting dowels at angles and things like that. This was done in 2 stages. You have the front part of the building leaving 1 door available so this could stay in operation. They wanted to make sure that they were an operational fire station the whole time. So the first portion was done in the front. Then once that was done, completed, they allowed it 7 days, but they allowed it to be operational with no traffic on it. Then they opened up the front section, closed the back portion, and did the back in the alleyway. That was the Class C2 exposure 32 MPa mixed use in that project. Next slide. So this is another project that was done in Courtney Park in Kidney. This was a reconstruction. There was a severe rutting at this in the asphalt. So what they decided to do was go with the concrete pavement in this area, and they used dowels for load transfer. And you can see that what happens here, because it was a turning lane, it was getting a lot of static loads on it, and they were getting, due to the braking and the resting of the heavy trucks in this area, they were getting severe rutting. So they replaced this area with concrete. Next one. Next one is Harwood in Bailey. This is an Ajax, and I actually was out to look at this not too long ago. So what they had is, again, they had some issues with raveling, there was flushing, there was rutting, there's some distortions, they had longitudinal cracks, and they had transverse cracks in the asphalt. It needed to be replaced. They made the decision to go with a concrete pavement because of the amount of trucks they had in this area. So they ended up going with a 200 millimeters of concrete pavement, and they have dowels for the load transfer, and they put tie bars. You can see the tie bars in the picture on the left to allow them to keep those longitudinal joints tightly together. You see on the right-hand side, they actually used supply the concrete instead of with the ready-mix truck here. They were using the boom to supply the concrete. Next slide, please. So this concrete here is being placed by a vibratory screed. And again, there was dowels placed, and you'll see that they have dowel baskets. Now, one key thing with these dowel baskets, they have to be secured properly to the aggregate base so that they can't be moved during the placing process. And this was, again, a Class C2, 225 millimeter pavement, Class C2 exposure, and the 32 MPa. And you see on the right-hand side that they put the white curing compound on the pavement to ensure that they keep the water in the pavement itself so that it can completely hydrate. And you want to make sure that the surface is covered very well so that you'll make the surface good and strong, and that you won't have evaporation occurring in that area and causing weaker concrete on the surface. Next slide. Here's another project. There's 200 millimeters of concrete pavement was placed at the bus pad. And in the bus pads, they were having a tremendous amount of rutting. Again, you got a heavy static loading, and you get the turning movement coming in and going out of it. So they chose to go with a concrete pavement, 200 millimeters with dowels. And they used a vibratory screed in this. They used a weight turn pound. You'll see that they're putting a room finish, a transverse timing, I should say, into the pavement. Next slide, please. So here's another project in Churchill, Windsor. This is actually a heavier truck traffic area. This was 310 millimeters with dowels. They also put an open graded drainage layer under this because this would have been an area that MTO may have been involved in. A lot of their very heavy traffic in the 400 series highways, MTO requires an open graded drainage layer underneath the pavement to enhance the drainage capabilities. I'm not a real big fan of open graded drainage layers because one thing, you'll get some of the concrete, some of the paste actually going down into the open graded drainage layer, which will change the effective thickness of the pavement, but also increases that tension between the concrete when it's trying to shrink. And if you don't get on and cut your joints early, you can get some ramming cracks developing, but there are some benefits certainly from the drainage point of view. Next slide, please. And here's another concrete pavement being placed in Brampton. This was a street that had a tremendous amount of deterioration in the asphalt pavement. And it was going into an industrial area. So they chose to go with concrete pavement. They were doing this one by hand finishing. He's doing some bow floating right now, some hand finishing. You can see the guy on his knees. They do have dowels in this. Again, it's 200 millimeter pavement with dowels. They placed 150 millimeters of Granite A underneath it. And they did put a broom finish in this because it's slower speed, so they didn't need the timing. And then they used white curing compound on it again for the curing. Next slide, please. And this is north, Parkdale North in Hamilton. You'll notice on the left-hand picture that they've got tie bars into the curb and gutter when that was originally placed. So what they're trying to do here is make it an integral curb and gutter so that part of the load on the concrete pavement will actually be transmitted into the curb and gutter, and that actually allows you to thin up the pavement structure a little bit. And here they went with a 200 millimeter pavement on 150 millimeters of granite base. It was a Class C2 exposure again. Notice that we're always seeing Class C2 exposure. It's very important that you follow CSA 23.1 Class C2 exposure, and I'll have a slide on that shortly, to ensure that you're getting the proper, good concrete material. And this was a 32 MPa project. This one here, actually, they're putting microfibers in it as well, macrofibers in it, I should say, as well, to ensure that they could handle the heavy loads that they were dealing with here. Next slide, please. So in addition just to new construction, where you're actually putting a new concrete pavement, taking up all the asphalt, redoing some of the granulars in some cases, there's actually systems that are called concrete overlays. Sometimes concrete overlays are bonded to the system, or sometimes they're actually unbonded. And you can bond them to the system when you have an asphalt pavement that's fairly thick, and you're only getting the surface deterioration, maybe the top 50 to 100 millimeters, but you're getting the continuous wear and tear on that asphalt pavement. You can actually bond a thinner concrete on top of that, utilize the asphalt strength that's still left to bond to the concrete, and that will shift the neutral axis of the concrete lower and put the concrete more in compression and in tension. Concrete is stronger in compression than it is in tension. So the more you can have the concrete acting in compression, the more load it can take. So those are two systems, and if click again, you'll see the ones on the left-hand side are thinner pavements, the ones on the right-hand side are thicker pavements. And you use an unbonded when you have an asphalt pavement that's severely deteriorated and you don't want to have to remove all of it, or you have a concrete pavement below that's older and you want to bond a new, you want to put a new concrete pavement over it. As one of the examples I'll be showing shortly, you can do an unbonded overlay. Next slide, please. So we get the thinner and the thicker. Bond is integral, and the other one is that you have a stiff, strong base when you're doing right-hand unbonded designs. Next slide. Thank you. So what are candidates? What are you looking for in a job? Well, the one on the right-hand side is Bloor Street in Toronto, where they were having lots of issues because of heavy truck with rutting and shoving in this area. So you have to look at the traffic level, and you'll have to look at the condition of the existing pavement, and that will determine what thickness that you're going to go with the concrete pavement, but also what you're going to be having to do with the asphalt. We have to remove it all if it's in that bad a condition, or can use some of that asphalt structure there to help you in your new pavement design. When you're looking at design issues, you're going to look at versus thin versus thick. And when you're looking at thickness, that's going to tell you whether you're going to be able to utilize some of that strength in the asphalt that's left, if any. And then you're going to look at your joint spacing. What's the joint spacing going to be compared to the thickness of the pavement? And you're going to try to decide whether you want to use dowels in it, and are you going to need to have tie bars and longitudinal joint. So you have to look at all these issues, and then construction issues. As I mentioned on the 7-3 fire station in Vaughan, we could have went with a dowel pavement and been a little bit thinner, but because of the complexity of the jointing and the configuration of the area where the fire station was, we chose to go with an undoweled pavement. So you have to look at that. You have to look at your concrete mixture. What strength you want? The strength of your concrete will affect the thickness. The load and the thickness and the strength are three of the key factors when you're doing the concrete design. Curing is a must with any concrete pavement, and sawing joints is a must if you want to control those saw cuts. Next slide, please. So this is Sprague Road. This was actually an old concrete pavement underneath an asphalt pavement. What they did is they had between 130 to 180 millimeters of asphalt that was actually starting to deteriorate substantially. And the decision was made, instead of knowing all that asphalt off and redoing an asphalt again because of the frequency of the problems that they're having, they decided to remove all of the asphalt, 130, 150, 180 millimeters. The exposed concrete that was there was not in very good shape. So they said, okay, let's go with an unbonded overlay. So they put 50 millimeters of asphalt back, and then they put a new pavement at 160 millimeters with a shorter joint spacing, so that it could actually have the panels acting more compression than tension, so they could decrease the thickness and don't have to worry about the elevations of the pavement. And they've had a very well-performing concrete pavement. It again was a 32 MPa Class C2 exposure. They used a burlap drag on this first to give the better micro texture, and then they did the timing of the surface on top after that, and they did the transverse timing. I actually like the longitudinal timing because it's actually quieter. The thing with transverse timing that you have to be very careful with, the deeper you put that timing, the louder the noise will come from your pavement. It doesn't have to be very deep to provide you that channel for the water to drain off the pavement and to provide the better pavement tire interface. But when you make it too deep, it will actually be a louder road. Next slide, please. Now this is another overlay. This was actually kind of a test section that was done. They were having, as you can see on the right-hand side, there was severe deterioration of the asphalt pavement. So what they decided to do, and this was an unbonded concrete overlay. This was a test section that they did 3 different stages. Section 1, they put down, it was an older concrete pavement underneath, so they put down a 25 millimeter, the section 1 actually, they put a geotextile down over top of the old concrete pavement to act as a bond breaker, and then put 100 millimeters of concrete back with a short joint spacing. It was 32 MPa Class C2 exposure with fibers to help with the strength again. The next section, they did a 25 millimeter asphalt overlay, and then they put the 32 MPa Class C2 concrete on top of that. The third section, they did a 25 millimeter asphalt separation layer. Then they put 32 MPa concrete class C2, but with microfibers. So now they have 3 different test sections that they're analyzing to see how this project will go. And it was built in 2016 and has performed very well. Next slide, please. So what are some of the key things then? We went through the benefits. We went through a number of different projects to show you that concrete pavement is being used. But what are some of the keys to good performance? Well, the most important thing that you want to have is you want to have uniform support. And you do this by, if you have a varying, if it's a long project and it varies, the strength varies, what you'll do is you'll transition from one type of subgrade type to another type of, so you'll blend them in together in a 500-meter area so that you have a uniform support underneath your concrete and you don't have to worry about hard soft spots. It prevents any cracking that may develop in your pavement because you're going with a uniformly strong or uniformly weak area. Now, if you've got something that you're building over a peat, then you're going to need something like a lightweight cellular concrete as the foundation layer to build on top of. But that's kind of a rare case. You always analyze what your subgrade is and identify is it the right plasticity index, and if it's not, you can modify that with cement stabilizing the subgrade. There's a lot of things you can do, but you want to make sure that you have a consistent subgrade to work with. Next slide, please. Another key thing is uniform support is drainage, drainage, drainage. You can see from the slide on the right-hand side, they had a culvert failure, and there were some drainage issues. You have to make sure, no matter whether you're concrete or asphalt or even a chip seal road, you want to make sure that you provide the appropriate drainage to get the water out from underneath the pavement so that you won't have any failures on it. And a more simplified failure would be the one that you see on the right-hand side, where there's been a loss of support in the concrete, so you get some shattered slabs in that area. So that could be a culvert underneath there or whatever, but you need to make sure that you provide the appropriate drainage so that you can have the appropriate performance from your concrete. Next slide, please. So quality material is also very important. So we recommend following CSA 23.1, Class C2 exposure. So when you have a Class C2 exposure, CSA tells you that your maximum water cement ratio is 0.45. Now, if you're doing flatwork finishing by hand or by screed, you're probably going to be closer to 0.45. If you're doing a slip form paving process and you need a stiffer mix, you're probably at a water cement ratio of 0.4. You still have enough water in there to have complete hydration of the cement. You're going to have a lot less bleed water. So you're not going to have to put the curing compound on right away on a job that's being hand finished or being finished by a vibratory screed, where when you're dealing with the lower water cement ratios of the slip form paving machine, as soon as you slip form the material, you do a highway streaking straight edge to give it the smoothness that you're looking for. Then you're going to get the tining and put that curing compound right away to ensure that you seal that water in there so you get complete hydration of the cement and that you get a durable surface because you don't allow the water to evaporate from the surface. You also want a 32 MPa concrete in 28 days in an air category of 1. Now, the air content will actually depend on the maximum size aggregate. If you have small aggregates, you're actually going to have more paste because you'll have more paste around those aggregates. So you'll need more air entraining in there because there's more paste. The larger the size of aggregate you have, the less paste you have, so the less air entraining that's required to give you the same or equal performance. So you see the 28 to 40 millimeter aggregates, you need 4 to 7, where when you have a really small size aggregates, the 10 millimeters, you'll need 6 to 9. And that will give you the durability that you need for a freeze-thaw environment to perform, get a good performing concrete pavement. Next page, please. So then, as we're in Ontario, we're highlighting OPSS. The OPSS specs by MTO are very detailed, and there's the basic one would be 350. It's a construction specification of concrete pavements and concrete bases. But as with many specifications, they always reference other specifications So I just put a few of them down. You have your OPSS 13314, that's construction specification for untreated granulars, base, sub-base, base, surface, shoulder, and stockpiling. That's another key one. Then you have your specification for compaction. They have compaction requirements and densities that they require for your layers. And then there's OPS Muni 1350. Whoops, this last one. 50, and then we also have the OPSSD specifications, which are the specification for concrete composite pavement, utility isolations. You've got concrete pavement joining details. You've got concrete barrier and curbs with gutter details. So there's a lot of different OPSSD series drawings that you can obtain through MTO. Next slide. So what can we do as an association to assist you? Well, we can help perform preliminary designs. Both the Concrete Ontario and the Cement Association of Canada are not licensed to do final designs, although I work very closely with engineers to help them do the designs. I teach how to use the software, also discuss the jointing and the thickness designs, etc. But we as an association can only assist in that process. We can't do the final designs. That's why it's important to hire a good engineering firm that understands concrete pavement thickness design and jointing. A perfect example would be back when I looked at the Fire Station 7-3. We did the pavement design, thickness design, and then they were going to do the jointing plan themselves, and then they sent it to me to review. I reviewed it, and it had acute angles, it had slabs, widths, the slab lengths that were 2 to 1 instead of the 1.5 to 1 that maximum that you're allowed. There was just a lot of jointing issues with it. They didn't isolate the manholes and the catch basins and things like that. So it's very important to hire a consulting firm that can actually go through and assist you in doing the designs and coming up with a jointing pattern that will actually work for you. Construction guidelines, it's very important to establish those. We do have the OPSS specifications, but you have to understand the placing, the finishing, the curing, and the staging process, as mentioned in that Fire Station 7-3 again, City of Vaughan. That was staged in 2 different sections so that they could keep that facility operating as a fire station and providing a very critical service to the people in that area. Maintenance recommendations is another thing we can go over and help on. And in fact, our next webinar is going to be on construction guidelines, and then we'll have a following one that will talk about maintenance and reconstruction processes. And then we also have contact municipalities, representatives who have done this work. We went over quite a few of those jobs. We can always get you in contact with those people if you need to discuss or want to discuss, instead of with myself or Alan, want to discuss it with another municipal engineer. We have some contacts that you certainly can call and talk to on that. Next slide. Now time is for questions.
Okay, thank you, Tim. Sounds like we did have some issues with the videos, so we will edit those before we post them on YouTube to make sure the videos do have sound, so my apologies for that. We do have some questions that Tim and I will address. Maybe the first one I'll kick over to Tim. So the first question is, do you recommend sealing on the municipal side? So sealing the joints.
Sealing is, there's 2 things in the sealing. One is, do you seal the joints and widen it to get the appropriate layout for your sealant to perform as best as possible? I'm not a big proponent of using the full widening of the joint to get the proper shape factor, and using the back rod, because back rods actually can cause an issue if somehow they become absorptive or water gets trapped under where the back rod is. You can actually get some joint rot in those locations. So I prefer, like City of Windsor does not joint, does their jointing. They use the thin cut 3/16 of an inch cut, and they do not seal the joints. Some places use a 3/16 of an inch, and then they put some joint sealant in that. There's pros and cons to it. You really have to look at both aspects. The one thing, if you don't use joint sealant and you do use sand, you have to make sure that to maintain your concrete, you want to blow out that sand in the spring, because in the summertime, when the concrete will actually start to expand, because when it's in the winter, it's contracted to the smallest it's going to be. The summertime and the heat is going to come, and it's going to be the greatest size it's going to be. So if you get sand caught in those joints because you went greater than the 3/16, then you may have an issue with maintenance. So I prefer the 3/16 of an inch and no joint sealing, but some people prefer even to seal the thinner cut.
Okay.
But don't use a backer rod.
Okay.
I'm not a big fan of that.
Okay. I can address the next question. What slump works best for concrete paving placement? So it really comes down to how are you placing the concrete? Are you using a slip form paver? You're probably going to be, much lower, 50 to 60 mils. You want a dry mix to make sure it stands up on its own when it is being put through the slip form paver. But if you are doing handwork, if you are using a vibratory truss screed or a roller screed, you can get your slumps up much higher, much easier to place. You can target, 120 mils to some of these jobs. That's what we use with Super Plasticizer. It's a lot easier for the crew to place. They're not breaking their back. So again, the simple answer to this question is it all depends how you're going to be placing this concrete pavement. And we will address this in future case studies in the next few months. Now, another question here is regarding tining. So from my experience, tining is quite rough. Is it required, or is a broom finish enough? Do you want to tackle this one, Tim?
Sure. It depends on the speed of your highway. If you've got a 50-kilometer section of roadway in a municipality, you don't need to put the tining. A broom finish is fine. Broom finish will give you the micro texture that you need for your skid resistance, and the slope of your pavement being sloped towards the curb and gutter will drain the water off your pavement. So the tining is not as necessary as it is on a major highway where you're doing 100 kilometers an hour, or some people faster. So it all depends on the speed, what you want to do. Like I said, I prefer the longitudinal tining. When you're doing a maintenance activity on your concrete, if it's a 30-year-old concrete and you want to refurbish it, and it doesn't have dowels, and you do dowel bar retrofitting and you had some faulting, then you're going to be doing some diamond grinding the surface. The diamond grinding is always done in the longitudinal direction. So that gives you a very quiet pavement, and it also gives you the area for the pavement water to go into when you're doing it, especially if it's grooved, where it has these extra channels for the water to go to, and you get very little splash and spray when you have grooves as well, because the water goes into the grooves and dissipates, is pushed away from the tire.
Okay.
So yeah, it all depends on your speed.
Okay. Just a few more questions. We're almost out of time here. When do you use bonded concrete versus unbonded in terms of overlays?
You use a bonded concrete overlay if you're at an intersection and you've got, some of them may have 300 millimeters of asphalt over it, because you just keep on putting the material on it and on it. And the deterioration is only in the top portion of the asphalt, say the top 150 millimeters. You could actually mill the deteriorated asphalt out, and then utilize that strength of the asphalt that's still there. So depending on how much is left, you need a minimum of 75 to 100 millimeters of the asphalt left if you're going to do a bonded concrete overlay. So you require that. A milled surface is a great surface as long as it's cleaned off. It's a great surface for concrete to bond to. And then you're also going to go with very short joint spacing, could be to a meter to a meter and a half. Again, making that concrete into shorter panels, which is going to maximize the ability to be in compression rather than tension. So it depends now. If you have a concrete that's in really good shape and you just had a change in your traffic and you know it's going to require to be thicker, if the concrete's in good shape, you can clean the surface of the concrete off and bond a new layer of the concrete to the concrete and match the joints. The joints have to be matched, otherwise they will reflect up through because the stiffer pavement will rule where the crack is.
Okay. And we'll take one more question. There's plenty of questions coming in, so thank you very much. Unfortunately, we are almost out of time here. So Tim, one last question. What would the minimum recommended thickness of concrete base for a composite road in a local residential street be?
Concrete base, so are they talking about the aggregate underneath, or are they talking about the concrete thickness?
If you're doing a composite road and you want to use concrete underneath, what would be the minimum thickness?
Oh, it all depends on the load. So they're thinking of building the concrete and then putting an asphalt over the top of it?
Yep, sounds like it.
Okay. Well, that all depend on the loading that they have on the pavement. Is there a truck route? Or is there buses that operate on it? Assume there's going to be garbage trucks for sure, but is it a bus route? That will determine, is there any truck traffic that would be going on it? Those would all depend on how thin you would get with your pavement structure.
Okay. Thank you very much, Tim, for your time. We really appreciate your expertise. And I'm sure we'll hear from you again. Now, moving forward, the Ontario Good Roads Association is highlighting many municipal concrete projects with their Municipal Concrete Award. The first annual one was just given away to the project that Tim worked on. The City of Vaughan 7-3 Fire Station won the first award, and we're looking to highlight many more in the near future. We do obviously have still many questions, so feel free to reach out to myself and Tim. We will be sending this presentation and the recording to everybody in the next couple of days. Again, we really appreciate your participation. Our next webinar is June 9th, where we will be focusing on municipal concrete paving construction. Myself and Tim will be back to highlight some of the construction practices that are used, whether it's slip form paving or using fixed form paving. There's different ways to place the concrete, so we really hope you guys can join us on June 9th. I will be limited to 100 participants, unfortunately, but again, we do appreciate everybody joining us today. So thank you very much again. We will be back on June 9th to provide more of an overview, and really hope that you enjoyed today's presentation. Thank you and have a great day.